Today we're going to be talking about physical geography, both in the real world and in Breath of the Wild. Uh, Physical geography is concerned with literally the physics and physical properties of different components of the Earth system and the physical rules that govern the way they interact. And these rules are replicated to an extent in the game Breath of the Wild, which makes it a nice sort of simplified case study for introducing yourselves to physical geography. Now, when you think of geography, you probably think of maps, and you might think of like cities and roads, and that is geography, but it's something called human geography. Physical geography is concerned with the physical aspects that create the landscapes and climates we observe in different parts of the world. These landscapes and climates are the result of a number of converging and interacting physical attributes. The interacting forces studied in physical geography are called the atmosphere, the hydrosphere, the lithosphere or geosphere, and the biosphere. So atmosphere describes all of the gaseous elements present on Earth. The bubble of air that surrounds the Earth up to a certain altitude and protects it from the vacuum of space. When you talk about the atmosphere, you're talking about the air, its composition, and the way it moves in global patterns around the Earth system. Then we also have the hydrosphere, so that's all of the water that is present. It's the oceans and the rivers, lakes. It's also groundwater, which is water contained within the soil, as well as water that's present in air, such as precipitation or rain and humidity. And then we also have the lithosphere or geosphere, and that's all the rocks. The soil and sediments, the mountains and volcanoes, as well as the tectonic plates and parts of the Earth's crust below the surface that become mountains or erupt from volcanoes, making new land. And all three different classes of rock are represented. So here we have sandstone in the desert, and that's a sedimentary rock. We also have what looks like granite, which is a metamorphic rock. And if you travel to the volcanic region, obviously we have igneous or volcanic rock, all represented in the game. And finally, we have the biosphere, and that's all the living components that interact with the other three. And the biosphere is unique is that it's composed of biotic parts and pieces, organisms, while all the other three are abiotic or non-living. And of course, this contains the plants, which is going to be the main focus of this course. But the point is that all of these different aspects interact with one another. And depending on the different variables of their interactions, end up shaping unique environments. The biotic components of these environments develop to be best suited to those particular conditions. This leads us eventually to the biome classifications, which is a useful way of describing typical geographical aspects of different areas and what to expect from a certain place as far as climate, annual weather, and plant and animal communities. So, first of all, about physics. There's been a lot said about physics in Breath of the Wild, which were developed purposefully to allow the player freedom to explore and experiment in the game's extensive world. So, for example, here is one of the fire mechanics. If you try to build a fire with flint and wood and hit these with metal, normally you'd build a fire. That doesn't work in the rain, but here in the shelter from the rain, it does work. And what is subtle enough to perhaps overlook is that these same physics apply to and shape the natural world. So as we explore these different regions, I want you to pay attention to the different gauges in the bottom right corner of the screen. Most notably the temperature gauge, because that's going to give us some idea about how air temperature changes in different areas. So here in this cold area, you see it's very far to the left, it's super cold, and then when Link jumps into the hot spring, it goes way up. And so that gauge is going to give us an idea of something we can't directly observe, which is air temperature, and in some cases also humidity levels. And these do behave more or less the same way they would in reality. So you have cold temperatures at the top of the mountain. Desert temperatures are realistically very high at midday, but they get very cold at night. And also weather patterns are appropriate to what you would see in real areas that look like this. And there are two important takeaways here. One is that the player has to respond to the changing temperatures and weather patterns or risk taking damage. So you have to protect Link from cold or hot temperatures, and here he just got out of cold water. And then here he is in the desert, and it's way too hot. So even when he puts on the desert outfit, it's still too hot because it's the middle of the day. And this is just an example of how far they take the physics. You see when Link runs into the shade, you can watch the gauge go up and down as he goes in and out of the shade in the sun. And that's not just in the man-made shrine there. It's also when Link is in the shade of the rocks. He can tolerate the heat. But then when he steps back out into the sun, it's too hot for him. The other takeaway here is that the physical aspects are consistent with corresponding biomes that would be observed in real locations with these geographies and climates. I think this is partially because certain areas of the map are modeled after real locations, but following a framework does allow room for creativity if you understand the framework. So you have to know the rules in order to break them effectively. And by studying physical geography, we can understand these rules and why these areas are different from one another, and why these areas are distinct enough that we can classify them. Understanding the whys is especially useful when you're trying to apply this information creatively, because it ensures that when you do creative world building, your ideas and creations are grounded in reality. If you can explain why things are the way they are, it will help you to answer questions about your creative work in a consistent way and inform details that might be otherwise hard to grasp. And this will lend the world you've built a feeling of authenticity, because the reader or the player will also intuitively understand these rules at play. It will make the world feel more immersive and rich. So here's some game aspects I want you to keep in mind during the lecture today. The air temperature is cold at high latitudes and also at high altitudes. So here, if you watch the temperature gauge as we're dropping in altitude and get over this landmass, the temperature increases. The air temperature is cold at night in the desert, but it becomes very hot in the daytime, so there's a big swing there. In general, humidity levels are higher in the eastern half of the map and lower in the western half of the map. And we can tell this because of the stormier and cloudier weather over here, and also by looking at vegetation. We would call this a maritime climate because it's near the ocean. The southeastern part of the map is frost-free. And again, we can tell this by looking at the vegetation. So if you look here, these plants cannot grow in an area that experiences frost. So we know that this is a tropical climate. And I know that because I know that I'm looking at bananas. And finally, a place's proximity to a large body of water will impact its climate and weather patterns. So it should be noted that the eastern areas are maritime while the western areas are continental. And while we're studying this map, I want you to pay attention to the lines that are drawn on here. You probably have an intuitive sense already of what it is that they mean, but they are derived from a tool that we can use to study geography. So with all of that in mind, I'll conclude the video and you can see the objectives for today's lesson, and we will move on to the lecture.